differentiate. Can you tell them apart? They're totally different. So what's f prime of x equal to?
20x cubed.
20x cubed, right? Now, so for one last time, I'm going to write it like this, right? It's 5 times, remember, it's the constant multiple, right? So it's 5 times the derivative of this, which is 4x cubed, but nobody says that, right? So this will be the last time we do this. It's just 20x cubed, right? Okay. But I just know where it came from, right? I mean, know that if you do have to split it out, or if you do want to move the 5 in front, you go, it's 5 times the derivative of 4x, or of x to the 4th. Okay, so in this one, it's going to be y prime is equal to, so we got a little work to do, right? So we're going to have to take that x times the cube root of x squared and get 1x out of it, right? Which is in exponential form, not in radical form. Okay. So we're going to say, what is it? It's 2 over x times x to the, so what's the exponent on that? You got 2 chances of getting it right. No, sorry, you got 1 chance. You got 2 reasonable guesses. All right, what's the exponent on this? This. 2 over 3, right? Good. 2 over 3, right? Okay, so combining these two, we get x to the 1 2/3, 5/3. Yeah, 1 5/3, right? Okay, so this is x to the 5/3. But we still can't work with that, so we do this, right? That's way too big. So we get 2 times x to the negative 5/3. Okay, now we can do this. So what is y prime? You want to do the whole 2 times, and then the derivative just goes straight to the. Either way. All right, for old time's sake. So it's 2 times what? Well, so the negative 5/3 comes out here, right? Negative 5/3 x to the. So what do we do with the exponent? We subtract 1
to the negative 8/3.
to the negative 8/3. Yeah, at some point you're actually going to get reasonably good at, manipulating thirds and halves and, Okay, so that'll be negative 10/3 x to the negative 8/3. And unless this is multiple choice and you can sort of see that the answer is left in that form, then we're going to have to take it back into a radical form. And so, what's it going to be? Oops. Just made a space there. What goes where? Yes.
It's the 3rd root of x to the power of 8.
There you go. Okay, good. So I think, if you're going to show much work, you kind of at least want to get this written down, right? Like for written work, showing stuff, you want to at least show that, hey, I'm converting the radical to exponential, and I've got this, and then maybe kind of go from here to here to here. Okay, so whatever, just, if you try and do too much at once, you'll know, right? Because you'll get the wrong answer. And remember, right, fix-it, focused practice, right? Which means that you're going to do a question and then check the answer. So if you get it wrong, you can at least look at it and say, oh, what did I do wrong? What's g of x if g prime of x is negative 6x cubed? So what did we start with such that we ended up with a derivative of negative 6x cubed. Yep.
It's a constant times x to the power of 4.
Okay, well, so we know that we're going to have an x to the fourth, right? Now, so that 4 has to come down and multiply something such that we get negative 6.
The constant times 4 is
What's
equal
the
to negative 6.
Okay. So what's the constant?
Negative 3/2.
Right. Okay, so it's negative 3/2 x to the fourth, right? So we know we got to up the power by 1. And then we know that that 4 is going to come down and multiply something such that, 4 times, let's call it a. Let's not call it x, just because we already got an x in there. Such that 4a is equal to negative 6. So you might be off here just sort of doing a little bit of 4a is negative 6, and a is negative 6 over 4, and we should reduce that, right? We've got negative 3. Okay, good. Now, is that the only thing that could give us that answer? Or this answer? Is this the only thing whose derivative we could take and get this? We're going to examine that. So let's just say, are there other possibilities?
Not good, right, and wholesome ones.
Yeah, that's true. There are, but they'd just be more complicated and
Anti-American.
against the nature. Yeah, especially if you're Republican. Democrats might be willing to accept. It's all going out on YouTube. Use first principles, the definition of a derivative, to determine. We're not quite done with first principles. Okay, so f prime of x is the limit as h approaches 0 of f of x plus h minus f of x over h. This is the preferred one. Some of you guys like the x minus a. I think this one's easier, better. I just like it more. I don't know. Just, Okay, so what do we do? The limit f of x plus h, right? So what is that? It's going to be 5 times x plus h quantity squared minus 2 times x plus h plus 3. Okay, and let's separate that. Minus 5x squared minus 2x plus 3 over h. Okay, and so now we expand that and collect terms, and go ahead, start expanding, collecting, multiplying. So don't forget, so I'm just going to move slightly left so that I have some room. I did have one shot, so what is that? It's x squared plus 2, so it's x squared, it's going to be 5x squared, plus 2xh plus 10xh plus h squared, which is going to be 5h squared, minus 2x minus 2h plus 3 minus 5x squared plus 2x minus 3. And I guess I didn't really need that opening parenthesis, did I? Over h. Please correct me when I make mistakes. Okay, now. We know what happens, right? We've seen this pattern before, right? So we know that, yeah, hey, you got the minus 2x here and the plus 2x here. And, it's minus 5x squared and 5x squared. And all we're left with is terms with an h. So let's go one more limit as h approaches 0. Factor the h out, right? We got 10x plus 5h minus 2 over h. Now this is the point we drop the limit sign, right? As opposed to in some of your written response where it kind of disappeared after the first line for some reason. What do we end up with? 10x minus 2. stuff. Good? Everybody got that? There's got to be an easier way. Especially when the title of the lesson is the sum and difference rule.
Oh.
So, if g of x is 5x squared, and h of x is 2x, and p of x is 3, determine g prime of x, h prime of x, and p prime of x. Okay, pretty easy, huh? So what's g prime of x? 10x, right? This is it. So no more 5 times 2x, it's just 10x, right? H prime of x and p prime of x. 0. Ha! And this goes back to what I think you were hinting at when you were talking about constants.
Sure.
Yeah. And if not, I'll take credit for that. Now, what would happen if f of x was g of x minus h of x plus p of x? How does f prime of x relate to g prime of x, h prime of x, and p prime of x? Okay, so what if f of x was the sum and difference of these guys?
It's the same as the sum and difference of all the primes.
Exactly. So f prime of x is going to be 10x, so right, g prime of x minus 2 plus 0. Right? And we got 10x minus 2. Now that was exactly the same, right? What did we find the derivative of? 5x squared minus 2x plus 3. By first principles, we got 10x minus 2. And by doing this, we got 10x minus 2, right? So that just g prime of x minus h prime of x plus p prime of x, right? It's just the sum and the difference of the individual derivatives. So the sum and difference rules. If f and g are differentiable functions, then so are the sum f plus g and the difference f minus g. And f plus g prime of x is equal to f prime of x plus g prime of x, and f minus g prime of x is equal to f prime of x minus g prime of x. Or in Leibniz notation, we have the following. Right? I'm just going to the following. Right. D by dx of the sum f of x plus g of x is right. Okay. So the derivative of the sum of two functions is the sum of the derivatives, and the difference, the derivative of the difference of two functions is the difference. Difference. Okay, one page down, one page to go. Differentiate. H of x equals 4x to the 9th minus 3x cubed minus 2 over x to the 4th. Okay, so first thing we're going to do is we're going to separate this out into a sum slash difference. So we're going to say, all right, so h of x is equal to, talk louder, over x to the 4th minus 3x cubed over x to the 4th minus 2 over x to the 4th, right? So we've split it out as a sum. They all have that denominator, right? And then it's just, normally we'd work something like that from that line and be going up to the line that's above, right, to get that simplified form. But here what we're doing is we're splitting it up, so they all have to have that denominator. Okay, now we can simplify each term, right? So this is 4x to the 5th minus 3x to the negative 1 minus 2x to the negative 4. So h prime of x is first term. It took a long time. I'm not good without a calculator. 20x to the 4th. Okay, here, it's getting tricky now. Next one.
20.
Close.
3x to the negative
3. Yeah, come on. I need an operation here.
Plus 3x.
Plus, right? Minus 1 times the minus here, right? So it's going to be, you could think of it as it's negative of negative, yeah, okay, it's just plus, right? So plus 3x to the negative 2, right? Down by 1. Okay, then, don't say, give me a, yeah,
Plus
plus,
8x.
thank you, to the negative 5, right? Okay, so we can then factor out the lowest power, right? Because the lowest power is kind of common. So what's the lowest power? I'm going with, I think negative 5 is smaller than either 4 or negative 2. So I'm going to take out a negative 5, giving me 20x to the 9, right? Because need to get a 4 out of that. Plus 3x to the 3 plus 8. Yeah, that's it.
It's not 8.
Just 8.
Don't jump out the window.
Why is 6 afraid of 7?
7, 8, 9.
Exactly.
Because 7 is a registered 6 offender.
Equals. All right, so what do we got? 20x to the 9th plus 3x cubed plus 8 over x to the 5th. Right, so we're looking at the derivative in basically kind of the same form that the original equation was given in, right? That as a single rational expression. Okay, it's all right. All right, moving right along. Determine d by du of 3 root u minus 2 times 5 minus 1 over root u. So, we're going to have to multiply that out and get a single polynomial expression, right? Well, it's sort of polynomial-ish. I guess it's not really a polynomial. So we want d by du of, okay, so FOIL, right? So 15 root u. Minus what? 3, right? Minus 3. Minus 10 plus what?
2 over root u.
2 over root u. Which is equal to d by du of, so now we're going to collect terms together. So what are we going to do? And what else do we want to do? We want to change the root u's from radical form to exponential form, right? Okay, so let's do 15 root u is what? 15u to the half. Okay, let's bring the 2 root u next, so we've got our u's together. So what's the plus 2 over root u? So plus 2u to the negative 1/2. Yeah, okay. And then what's left? Minus 13. Because what's the derivative of a constant anyways? 0, right? So it's better to have that last, right? Because we know that, there's nothing will result from that. Equals. Okay, so now we can do this, right? So 15u to the half is, what's the derivative of 15u to the half? No. Leave fractions.
No, right.
You want fractions, right? Because because you're gonna have a u to the negative half, and the negative half's gonna have to go down under, and you can't have like 7.5. You don't want to go there. Fractions. Right. So 15 halves u to the negative 1/2 Okay, next. Well, 2 times negative a half is,
Negative u to the negative.
so negative 1, so negative u to the negative 3 halves, right? No,
Sorry, negative.
no. Yeah. Okay, so are we going to write that? No. Right. So we're not going to write the 0. So just say, hey, okay, there you go. That's it, right? If you really feel you need it, you can put like minus 0. We want to factor out the lowest power of u, which is u to the negative 3 halves. And numbers, there's no common factor number-wise, right? Okay, so we're just common factoring out. So we're taking out a u to the negative 3 halves. So I'm going to get 15 halves what? So this times something has to equal this. What are you going to put there? You should just you. It's all about you. So it's just you, right? So you're going to get used to this, right? You're just going to get used to these negative powers, right? Factoring out the negative powers and all of that. And it's kind of neat in a sense, right? Hey, I just get a u there, right? Or, because these are separated. Minus what? Right, because, you're number 1, so. Minus 1. Okay, so, but you know what would be nice? Because actually we have a denominator, right? So really, let's take a 2 out of there as well. And let's do that. So now we get a nice expression, right? 15u minus 2. And this way, and actually, you know what? We could even write it this way. Let's go. It's 1/2 of u to the... So now we have our numerator, which is 15u minus 2, and we have our denominator, which is 2u to the 3 halves. So there. That's a much cleaner way of doing it, right? So instead of just factoring out the u, we factor out basically what's going to end up in the denominator, right? So 1/2, and then the u to the negative 3 halves, the lowest power. And then what's left? 15u minus 2. And now what? Well, now we could put the 2u to the 3 halves down in the denominator where it belongs. There it is. Nice and clean. Now, of course, what should we do with the u to the 3 halves? Because what form was the original, right? So we've got radicals sitting here, right? So we want to radicalize things. So 15u minus 2 over 2, square root of u cubed. Okay, so we're going back into radical form, right, from exponential form. It's all right. Determine the equation of the line tangent to f of x equals x squared minus 3x at x equals 2. Express the equation in the form blah, 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 blah. Okay. So what's the slope of the tangent line? F prime. Let's call it prime. So the slope of the tangent line is the derivative, right? Okay, f prime of x, which is, now we can do this, right? What's the derivative? 2x minus 3. Okay, that's the slope of the tangent line. Now, we want that slope when x equals 2. Okay, so we could say, well, okay, the slope we're interested in is f prime of 2. So I'm not going to write an equal sign here because this is not equal. Like, I've got that, but I do need to know the slope at 2. So f prime of 2 is 2 times 2 minus 3, which is 1. And what else do we need? So we got the slope, and we need a point. So we know that x is 2, but we need to know what's the y value. What's f of x, right? So when x equals 2, f of x is equal to 2 squared minus 3 times 2, which is, in one fell swoop, negative 2, right? We got 4 minus 6, negative 2. So the point is 2, negative 2. All right, we got a slope, we got a point. Use your favorite method, whatever. I'm a point slope guy. You can use slope y-intercept if you like. I like point slope. So y plus 2 is 1 times x minus 2. So y plus 2 is x minus 2. So x minus y minus 4 is 0.
A must be greater than 0.
A is greater than 0.
Oh, wait, yeah, okay.
Okay.
It's 1, I see.
Yeah. So it just means it's got to be positive, right? We got to lead with a positive x, and they got to be integers, so you can't have fractions, right? So if the slope was a half, then we'd be multiplying through by 2. So at this point, what I would do, like, you know, if I was sitting at home or whatever, you've been sitting in class, I'd graph it just for the heck of it, right? I just want to see this, you know. I just kind of like to see it. Say, hey, yeah, it really is, you know, it's kind of neat. I'm not going to though, but you know, if you were in Desmos or something, yeah, that's what I would have handy. Like, why don't bother graphing calculators? They suck as far as graphing, right? But Desmos is nice. Nice display. You can see things, and it'll highlight what 3 out of 4 times it showed us a tangent point, and then 1 time it didn't. So, you know, I don't know why or why not. Determine the equations of both lines that pass through 1, negative 11, and is tangent to. I think that should be an R. 1, negative 11. So what's... That's down there. So, yeah, what's going on? Okay, whoa. What is going on? So, tangent, all right, so somewhere, this is going to be tangent to, you know, I'm thinking maybe around there, depending on the accuracy of the drawing. Whoops, just getting less accurate. And then somewhere kind of on this, right? So the idea is we're looking for 2 tangent lines that pass through the point 1, negative 11. So we got 1 point. And, well, we can get a slope of the tangent line, right? Okay, so maybe we should start there. So the slope of the tangent is f prime of x. So let's do that. M tan. That's a big prime. F prime of x, which is still amazingly 2x minus 3. Same. Okay, so I know the slope of the tangent line, and I know 1 point. So we're going to have to find another point, right? The point of tangency action, right? So somewhere up here at x comma f of x, right? Or x comma y. Or think of it as the point, you know, x1, y1, I guess. So what's the slope of this line? I don't know, should we just call this x? Well, let's call it what it is. X and x squared minus 3x, right? Because that's f of x. That's what the y coordinate is. It's x squared minus 3x. So we know the slope of the line we want to find is rise over run, right? y2 minus y1 over x2 minus x1. So what we're looking at is we got two ways to define slope, right? One way we know is that it's the derivative of the function. And another one is, well, we want to find the line that passes through 1, negative 11, and x squared minus 3x, right? Which is going to have the same slope. So at some point, we have two different expressions for the same thing, which means we can set them equal to each other, right? Okay, so what's y2? Well, let's go with it's going to be x squared minus 3x minus negative 11. So let's go plus 11. Okay, so that's y2 minus y1, right? Just some point on the parabola over x minus 1. So if the slope of the tangent is 2x minus 3, but simultaneously and together at the same time, it's x squared minus 3x plus 11 over x minus 1, what are we going to do? We're going to set them equal to each other, right? We have two expressions for the same thing. All right, fine. So let's set them equal to each other and see what happens. So that means that 2x minus 3 is equal to x squared minus 3x plus 11 over x minus 1. Let's toss that in. So what shall we do? Multiply both sides of x minus 1 and solve the resulting quadratic? Knowing that we should get two x values, right? Because we're going to have two tangent lines. All right, let's do it. So 2x minus 3 times x minus 1 is equal to 2x squared minus 5x x squared minus 2x minus 8. I'm thinking. Remember, your job. Make sure we get a good video out of this. That's right. Plus, minus, yeah, okay. So we think that x is equal to 4 or x is equal to negative 2. So I really should have put the point there. There. So we got one line. Oh, dang. The line's on the frame. That doesn't cut through, it just hits tangent there. And the lines continue, but I can't get down there. And what did we have to, oh, we needed the equations of the lines, right? Okay, so we have two things to work out, right? So when x is equal to negative 2, then we have the slope, right? And what's the slope? It's going to be f prime of negative 2, right? So when x equals negative 2, the slope of the tangent is f prime of negative 2, which is, what was the slope of it? It was 2x minus 3, right? So 2x minus 3, which is negative 7. Right? Yeah. And what's the point it goes through? Okay, so the point it goes through is f of negative 2 is, what was f? It was like x squared minus 3x. So f of negative 2 is negative 2 squared minus 3 times negative 2, which is 10. So the point is negative 2, 10. Actually, we didn't even need that, did we? Because it goes through 1, negative 11. Right? So you could use either point, right? We just need the slope and a point. Probably should have used one thing. I was drawing the diagram, it looked better, I don't know. So y minus y1 is m, x minus x1, right? Or just use 1, negative 11. To save time. So y plus 11 is, what was m? It's negative 7. X minus 1. Scroll down. Y plus 11 is negative 7x plus 7. Positive a, so we're going to kick the negative 7. So 7x plus y plus 4 is equal to 0. So that's one tangent line. When x equals 4, the slope of the tangent, when m10 is equal to f prime of 4, which is 2 times 4 minus 3, which I think is not 8, it's 5. Well, okay, it's 8 minus 3, which is 5. And we're going to find the equation of the line. Y minus y1 is m. Okay, and the point again, right? You could just use 1, negative 11. So y plus 11 is equal to 5x minus 1. Y plus 11 is 5x minus 5. 5x minus y minus 16 is equal to 0. Make sense? So watch for something like that on a quiz or a test or something, right? And just keep in mind this example of, you know, what are we drawing? Tangent line to a parabola through a point that's, you know, down below or somewhere, you know, it could be off to the side somewhere even, right? And it's going to have 2 points of tangency on the parabola. Done. Done?